Okay, now that we've learned all of our 6 trig graphs, we're going to start analyzing some information from them. First, talking about domain. Domain has to do with what x values that graph covers, or you can think of it as left and right. Your range has to do with the y values that graph covers, so your up and down. And then values is going to be covered later. It's a little different. So first, let's go through our 6 trig functions and pick out our domain and range for each. For a sine graph, my domain, since I'm going forever left and right, I'm going to list my domain as negative infinity to positive infinity. For my range, I'm looking up and down, and you can see your sine graph only goes from -1 to 1. So you're going to list it like this: bracket -1, comma 1. The brackets mean including -1. If you're using parentheses, like we did on infinity, it's up to but not including infinity. You always use parentheses on infinity because you can't actually get there, so it's just up to. Cosine has the exact same domain and range. I'm going left and right forever, negative infinity to positive infinity. My range, up and down, same thing, -1 to 1, inclusive, meaning brackets. Okay, for tangent and cotangent, now we're a little different. Domain. The pattern keeps continuing left and right forever, but wherever I have asymptotes, that's what is not included in the domain. So I'm going to list my domain something like this, and there's a bunch of different ways to do this. My domain is all values of x. So let's start with bracket, all values of x such that, which is a vertical bar, x does not equal. Now where do our asymptotes land on tangent? Well, the first one is at pi over 2, so that's what I'm going to write. First positive one is at pi over 2, plus, how often do they occur? Distance between till the next one is a distance of pi, so I'm going to list that as pi k. So my domain is all values of x such that x does not equal pi over 2 plus pi k. Pi over 2 plus any whole number multiplied by pi. So plus pi would land at 3/2 pi. Plus negative pi would land at negative pi over 2. Range, up and down, how far does tangent go? Forever. Negative infinity to positive infinity. Range on, or domain on cotangent. Fancy bracket. All x such that x does not equal. First positive one is at pi plus, how often does it occur? Every pi distance, so pi k. This could be simplified to pi plus pi k. You could just list it as pi k because it's whole number pi. Range, my up and down, would be negative infinity to positive infinity. Cosecant and secant. Domain. This one has asymptotes, so we use fancy brackets. All x such that x does not equal. My asymptotes in cosecant are landing on pi, 2 pi, 3 pi. So every pi k. Every whole number pi. Range, up and down. This one's a little different. Okay, my range is coming from positive infinity all the way down to 1, including 1, and then -1, including -1, to negative infinity. So here is how I write that. I go start from your least to greatest. So negative infinity up to -1, including, and we union them, 1 to positive infinity. For secant, it's going to be very similar. Domain, all x such that x does not equal. This one starts on pi over 2 and repeats every pi k. Range actually has the exact same range, negative infinity up to and including negative 1, and, so union, positive 1, okay, that should be a positive 1, to positive infinity. Okay, now let's move off of our regular graphs and think about a translated graph. Okay, what's this graph going to look like? It's a cosine graph. All cosine graphs go left and right infinity, so I know my domain is going to be negative infinity to positive infinity. My range is probably going to change. This graph has an amplitude of 2, so that means from the x-axis I'm going to be going up 2 and down 2. So that means this graph is only going to be going from negative 2 to positive 2, and that's exactly my range, inclusive, negative 2 to positive 2. Okay, find the domain of a cotangent function. Okay, I know it's got squiggles. This one I'm probably going to have to graph a little bit more than I did for the cosine. Alright, it's cotangent, so it starts at 0 unless I have a shift, and I do. My shift is going right, pi over 4. So instead of starting at 0, I'm going to start at pi over 4. So here's my asymptote. Period is equal to pi. So I'm going to go a distance of pi and write my other asymptote. Center of the asymptotes would be right here at 3/4 pi, and there's no shift up, so it is right there. And we know it's going to squiggle up and down. Asymptotes are really all I needed to know out of this. Domain, left and right. All x such that x does not equal. First one is at pi over 4. Repeats every pi k. Range, up and down, how far do the squiggles go? Negative infinity, positive infinity. Okay, try finding the domain yourself. Come back and check. If I'm dealing with a secant, I'm really thinking of cosine. And let's see, that's my amplitude right there. It's flipped over, but that really doesn't matter. It's not shifted left or right. So it's going to look like this, going from 1/4 to negative 1/4. And yes, it's flipped, but that doesn't matter right now. And then it's going to have some asymptotes. So it's going to look like this. What I really want to know, they're right here and here. The period ended, that's not an asymptote. Okay, the period ends. How long is the period? 2 pi. So my asymptotes are at pi over 2 and 3 pi over 2. So they are pi distance apart. Domain, left and right, we hit asymptotes. So all x such that x does not equal pi over 2 plus, how often does it repeat? Pi k. Range, starting from the bottom, I go to negative infinity all the way up to and including negative 1/4. Union, including 1/4 up to positive infinity. Okay, try another one before you check. This one is going to be moved up 4. Cosecant, I'm thinking of sine. So instead of starting at 0, it's going to start at 4. And it's going to squiggle up and down. So that means I'm going to have an asymptote on 0, halfway through, which would be at pi, and at the end 2 pi. So it's landing on every whole pi. Domain. All x such that x does not equal pi k. Range, up and down. I'm talking about the parabolas, so they're going from negative infinity up to 3, inclusive, union, including, let's see, that'd be 5, on up to positive infinity. Okay, now we'll get into the values. Find the values of x such that sine x equals 1 over the interval 0 to 2 pi. Where does sine x equal 1? Here's my sine graph. Here's 2 pi, pi, 1. This is what I'm wanting to know. When does the sine graph hit 1? Well, it's going to hit it right here. If I continued my graph, it's going to hit again right here. So where's that at? That's at pi over 2. My interval is only wanting to go from 0 to 2 pi. And in between that, it's only going to be 1 at one angle, which is pi over 2. So x equals pi over 2. Find the values of x. This is a you try it, so see if you can figure this one out first. Find the values of x such that tangent x equals 0. Now my interval's a little different. Tangent, centered, period of pi. So I go to negative pi over 2 to positive pi over 2. So there's my interval that's drawn right there. It's going to hit 0 only at one spot. The rest of it squiggles. So where does tangent equal 0? Well, only at 0. When I'm at pi over 4, I'm at 1, and when I'm at negative pi over 4, I'm at negative 1. So I'm only at 0 on the origin. Okay, a little bit different. Find all the values such that cosine x equals radical 2 over 2. Alright, radical 2 over 2 is a positive number. Here's my cosine graph. 2 pi, pi. It's a positive number, so it's going to be somewhere in here. You need to figure that out. Radical 2 over 2, you should think that you have seen that on the unit circle. What angle was radical 2 over 2 at? It was at pi over 4. That was the point radical 2 over 2, comma, radical 2 over 2. Cosine was the x-coordinate, and that's how we know. So I know this is happening at pi over 4. So this point that goes with this, pi over 4. So when's it going to hit it again? Okay, think about what quadrants we're talking about. Remember when we rolled out the unit circle? This was 1, quadrant 2, quadrant 3, quadrant 4. So it's also going to hit in quadrant 4. So you have to figure out what angle that's going to be at. My reference of pi over 4, that's going to be 7 pi over 4. Okay, how do you write this answer? Well, first of all, x equaled pi over 4. How often is that going to repeat? How big's your unit circle? It's going to hit pi over 4 here. And I'm going to make another period, and it's going to hit again. What was the distance between the two? The same as a period, 2 pi. Going to tack on a k. because we can add 2 pi however many times we want, and we're still going to be at radical 2 over 2. You have your other solution at 7 pi over 4, and it's going to repeat just as often. Okay, try to figure out where cosecant x equals negative 2 over radical 2. So if I'm talking about cosecant, I'm actually referring to sine. And this one I'm going to have to go from the unit circle. Okay, where cosecant equals negative 2 over radical 2 is going to be where sine x equals negative radical 2 over 2. Where's that going to happen? Well, if I think about my sine graph, it's going to hit twice in the negatives. That's quadrant 3 and quadrant 4. So if I think about my circle, over here, what angle will I be at if I'm going to hit negative radical 2 over 2? I'm going to have to be at 5 pi over 4. So there's one answer. How often does sine repeat, cosecant repeat? Every 2 pi, so 2 pi k. Where's the other one at? It's going to be in quadrant 4. And that's going to be 7 pi over 4. So that's plus how often it repeats, 2 pi k.